Let's start with a question, a really simple one. Or at least it seems simple. Have you ever really stopped to think about whether you're moving right at this very moment? The answer is one of the coolest ideas in all of physics. So let's dive in. Are you moving, or are you perfectly still?
Okay, so you're probably sitting down, maybe in a chair, feeling pretty stationary. And you're thinking, of course I'm still, right? But what if I told you that you're also hurtling through space at a mind-boggling speed? The crazy thing is, both are true. And figuring out that little paradox is what we're going to do right now.
All right, before we can really solve this puzzle, we've got to make sure we're all on the same page. We need to lock down what rest and motion actually mean when physicists talk about them.
Let's kick things off with rest. In physics, something is at rest only when its position isn't changing. And here's the crucial part, relative to a specific point of reference. So yeah, if you're sitting on a park bench, you are definitely at rest compared to that bench and the trees right next to you.
And motion, as you probably guessed, is just the opposite. It's anytime there's a continuous change in your position compared to that same frame of reference. The second you get up from that bench and start walking, well, now you're in motion compared to the bench and those trees. Simple enough.
Okay, so you're either at rest or you're in motion. Seems pretty black and white. But here's where things get really, really cool. It's not actually an either-or situation. And the key to understanding why is a huge idea called relativity. This right here, this is the whole secret. Whether an object is at rest or in motion is never an absolute, unchangeable fact. It always, and I mean always, depends on your point of view, what scientists call your frame of reference. Let me give you a classic example. Imagine you're on a bus, sitting with a friend. From your friend's point of view, from your shared frame of reference, you're perfectly still. But now, picture someone standing on the sidewalk watching you go by. From their frame of reference, the street, you and your friend and the whole bus are obviously in motion. So who's right? They both are. You're at rest and in motion at the exact same time. We can take this idea and just scale it way, way up. Right now, you feel stationary because your frame of reference is the room you're in and the Earth itself. But the Earth is spinning on its axis and rocketing around the sun at about 107,000 kilometers per hour. So if you change your frame of reference to the sun, you are absolutely, definitely not at rest. It all just comes down to your point of view. So, now that we've got our minds wrapped around the idea that motion is relative, let's break it down a bit more. Because it turns out, not all motion is the same. Physicists generally sort it into three main categories. We can pretty much break down all movement into these three buckets: translational, rotational, and vibrational. So let's take a quick look at each one. First up, we have translational motion. This is probably what you immediately think of when you hear the word motion. It's just an object moving from point A to point B. This can happen in a straight line, which we call rectilinear motion, or it can happen along a curved path, which is called curvilinear motion. Next up is rotational motion. This is anytime an object spins around a fixed point or an axis. A Ferris wheel is a perfect example, right? The whole thing just turns around that one central point. Or think about a simple wind vane spinning in place whenever the wind blows. And finally, there's vibrational motion. This is a repetitive back and forth movement around a central spot, what's known as an equilibrium position. Just picture a kid on a swing going back and forth, back and forth. Or imagine the string of a guitar right after you've plucked it. That super fast shaking is a perfect example of vibrational motion.
Okay, so we've got our definitions, and we've got our big aha moment about relativity. Now let's tie all of this back to that very first question and the world that's all around you.
You know, if there's one single thing to take away from all this, it's this. There's no such thing as absolute rest or absolute motion in our universe. It's always, always a relationship. It's a comparison between an object and whatever frame of reference you choose. So, let's circle all the way back to that first question. Look around you, right now. I bet you can spot all three types of motion happening. Maybe there's a fan rotating. Maybe your phone is vibrating. And hey, don't forget, you yourself are in translational motion as our whole planet orbits the sun. Once you realize everything is always in motion from some point of view, it really does change how you see, well, everything, doesn't it?